What's up guys, Major Math with another video on fluid mechanics. If you have any questions, drop it in the comments, and if you're having trouble with other problems, I've attached my email in the description, so please feel free to reach out. Without further ado, let's get started. Question 2.57, the textbook says water flows near a wall with a velocity distribution for water at 20 degrees Celsius near a wall is given by U equals A. Well, you can read it, where A equals 10 meters per second, B equals 2 millimeters, and Y is a distance from the wall in millimeters. Determine the shear stress in the water at Y equals 1 millimeter. Okay, first things first, write our goal. So we're going to want to find shear stress, which is represented by tau, that symbol, at the distance of the wall where Y equals 1 millimeter. We're given that this function for velocity, so in this case U is representing velocity, so it's saying the velocity, like by plugging in different distances from the pipe wall, you will get different velocities. So the function of velocity with this right here. Okay. And then we're given that A equals 10 meters per second and that B equals 2 millimeters, which is equal to 0.002 meters. And then we're saying that we're trying to find where Y is equal to 1 millimeter, which is equal to 0.001 meter. Okay. So to solve this, we got to find an equation that uses shear stress. If you look on this table here, you can see shear stress right here, definition of viscosity. It says shear stress is equal to the dynamic viscosity multiplied by the derivative of velocity with the respect of y, which is distance, distance from the wall. So we'll go ahead and write that. In this case, in the textbook it put a V for velocity, but I'm going to put U because that's what the question does. I don't know why they switched it up on us. I'll put a cursor. Okay, so we're trying to find shear stress, right? And we're given this function of U, and we know we can actually, so right here, this is the dynamic viscosity, and we can actually be given that in the textbook. Right here, for properties of water, we got at 20 degrees Celsius, we have dynamic viscosity, 1 times 10 to the negative third power. So we know from the textbook that dynamic viscosity is 10 to negative 3. What was the unit on that? Newtons times seconds per meter squared. Okay, so we know that. The only thing we got to solve for is this whole derivative mess. We're given a function of U, so we can rewrite this as, well, actually we don't want to rewrite it, we want to solve for this. So you know that, I'll write it down here, yeah. Equals the derivative with respect of y of this, right? Because this is our function U, and now I'm just writing it a little bit differently. It's the same, it has the same exact meaning, but now we're given this function U of y, right? So we can actually just go ahead and plug that in. Okay, so now we have to solve this derivative. So we have a derivative with respect of y of this equation. And remember that a and b are constants in this situation. So we will be treating them as if they are a number. If you take the derivative of this, use the old, I think it's called a chain rule. I think it's called a chain rule. I know how to do it, so it will be, right, you take a out in front, and then you multiply by 1 over 6, and then you leave the inside, it's y over b. You might subtract 1 from 1 over 6, so you get 5, negative 6, and then you multiply it by the derivative of the inside, which is 1 over b. Let's simplify that. We get a over 6 times b. So that's a 6, and that's a b right next to it. Pretty similar. Multiply by y over b to the negative 5/6 power. Okay. So that's what the derivative equals. So now we can go ahead and solve for this and plug in our y value, our b value, and our a value. Let's go ahead and do that. We got 10 meters per second over 6 times 0.002 meters. And then y, we're wanting to do 1 meter, 0.001 meter, and then b is like this again, to the negative 5/6. Okay, and then we put that in the calculator, and that gives us about 1.485 I don't know how you say that, seconds per second. It just gives us seconds. But now we have to plug it into our viscosity equation, because now we have everything solved for, all the unknowns. Find that shear stress. So we know from here, from the textbook, that the dynamic viscosity is 10 to the negative third newtons times seconds per meter squared. And we multiply that by seconds negative 1. And then that will give you a shear stress of 1.69 newtons per meter squared. And that is equivalent to pascals, right? I think that's what we said. Yep. Either way works. But that's how you solve that problem. This is our answer. That is the shear stress. Thanks for watching, soldiers. Don't forget to leave a like and subscribe for more content like this. If you have any questions, leave it in the comments, and if you need help with any other problems, feel free to contact me with the email shown on the screen.